We present Deeporgan, multi-level deep convolutional networks for automated pancreas segmentation. Pancreas segmentation is an important prerequisite for many computer-aided diagnosis systems, for example, for quantifying diabetes. However, pancreas segmentation is challenging because of the high anatomical variability of organs in the abdomen. Furthermore, it suffers from low accuracies when compared to segmenting other organs like the liver, heart, or kidneys. Typically, only less to equal 70% average die-scores are reported for pancreas segmentations compared to over 90% in other organs. Hence, we present Deeporgan, multi-level deep convolutional networks for automated segmentation of challenging organs such as the pancreas. Our system uses a set of manually traced segmentations of the pancreas in the lower abdominal CT images. We then train a superpixel-based random forest classifier that performs at high recall but with low die-scores of around 26% on average. These superpixels are then fed into multi-level convolutional neural networks to produce per-region and per-slice probability maps. These per-slice probability maps achieve around 65% die-scores and can be propagated to 3D using simple Gaussian smoothing, elevating the performance to 72% die-scores on average. Our implementations uses this typical architecture for the deep convolutional networks with 5 convolutional filters that are fed in the neural networks in order to produce a probability score for pancreas and non-pancreas. These convolutional filters are purely trained from the imaging data. Investigate 2 approaches. First, deep patch classification that takes a ground truth image and estimates candidate regions of superpixels via random forests, and then uses a 2.5D sliding patch window with orthogonal viewing directions to produce a ConvNet probability map. The other avenue is to use regional ConvNets for deep region classification. Here, each superpixel is cropped at a tight bounding box with different scales. We investigate including the intensity only and using the intensity plus the previously described patch ConvNet probability maps as the second input channel. Apart from different scales, we also look at the randomly generated non-rigid deformations for increasing our training data set and making the data set more balanced. This gives us about 800,000 training images for each training fold. A typical first layer convolutional filters are summarized in this slide for the 3 different types of deep convolutional networks. Here we show some example of convolutional filters that are learned as features for pancreas versus non-pancreas classification. Quantitative results are performed on 8200 enhanced CT scans from healthy kidney donors and randomly chosen in 4-fold cross-validation. In testing, the patch convolutional network performs already well at this operation point, while the regional convolutional network trained on just intensity alone performs slightly worse. However, combining both gives us a higher average die-score using the R2 ConvNet. The same can be seen in the quantitative results, with the best performance being at 71.8 die-score on average. Interestingly, the improvement between these different methods is better observed in the surface-to-surface distance error metric, where we significantly improved by using the R2 ConvNet setup. The surface-to-surface distance error metric is visualized here, showing the distance to the gold standard segmentations. We have 2 outlier cases where the die-score is low. However, 80% of our cases have 65% or higher die-scores. A final example of the segmentation results can be seen here, with the ConvNet probability map and the binary segmentation thresholded at its best performing operation point. In conclusion, ConvNets can be generalized to tasks in medical image analysis, such as the segmentation of the pancreas, we compare favorable to the state-of-the-art methods with 71.8 versus 71.1 to 73%. This approach has a lot of potential for improving with growing data. The proposed methods could be applied to other organs or multi-organ segmentations as well.